Have you ever just looked at the world and felt like there's some kind of hidden connection, a secret language linking things that seem totally unrelated? Well, you're not wrong. And today, we're going to decode that secret language. So let's just jump right in with a question. What on earth could the electrical sparks in your brain, the seismic shifts of an earthquake, and, the huge ground swells of social change possibly have in common? It sounds like a trick question, right? But I promise, there's a real scientific answer. And here it is. They all follow the rules of something called pattern geodynamics. Now, that might sound a little intimidating, but it's a really powerful way of seeing the world. And trust me, by the end of this, you're going to start seeing these hidden connections absolutely everywhere. Okay, so to really get this, we first have to learn the language that all these different systems are speaking. We're talking about a universal language of patterns that shapes pretty much everything. All right, I know. That definition looks like a mouthful. Spatiotemporal flows on constrained substrates. What does that even mean? Well, let's just break it down. Spatiotemporal flows, that's just a fancy way of saying patterns that move through space and time. And the constrained substrate, that's just the surface or structure they're moving on. So for your brain, it's the neural network. For a society, it's the social network. See? All it is really is the science of how stuff flows and forms patterns. Now, this idea didn't just pop up out of nowhere. It has some really deeper roots. In fact, a lot of the groundwork was laid by the writer Philip Ball, whose incredible trilogy of books gave us the vocabulary to even start talking about this stuff. His trilogy, Nature's Patterns, came out back in 2009, and it was a total game changer. It basically gave us all a new pair of glasses to see the world with. Suddenly, you weren't just seeing random things. You were seeing the elegant, self-organizing patterns that create everything from a river delta to a lightning bolt. And the core ideas, they're so beautifully simple. The book's shapes showed us how complex order can just emerge from simple local rules. Then flow came along and completely flipped our idea of chaos, showing us that instability is actually an engine for creating cool new patterns. And finally, branches pointed out that branching is like nature's favorite trick for moving things around efficiently. But here's the thing. Philip Ball's work was the essential foundation. But it was just the beginning. In the last 20 years or so, science has taken those ideas and completely supercharged them with modern data and computing. And this slide really nails the difference. Back in the day, we could describe a fixed pattern, like the stripes on a zebra. But now we can look at data and figure out the dynamic forces that are creating the pattern in real time. We went from analyzing simple models to understanding whole families of behavior, or regimes. But the biggest leap, by far, is this. We used to see tipping points as total surprises. Now, we can treat them as risks that we can actually forecast. Okay, to make this all feel a bit less abstract, let's zoom in on the most mind-bendingly complex pattern system we know of, the human brain. And I want you to think of it like a giant, chaotic orchestra. Because inside your head, right now, all these different patterns aren't just playing their own tunes side by side. No way. They are stacked, one on top of the other, in layers that are constantly talking to each other, shaping each other's behavior. It's this incredibly complex and beautiful dance. So at the very top layer, the one you can see on an EEG, you've got these big traveling waves. These are huge, coordinated waves of electricity that just sweep across the surface of your brain, kind of like ripples in a pond, carrying information all over the place. But if you dig a layer deeper, things get way more subtle. Every single neuron generates its own tiny electric field, and through something called epheptic coupling, those fields can actually nudge their neighbors into action without ever physically touching them. It's like neural crosstalk or the brain's own Wi-Fi system. And then there's layer 3, which is all about chemistry. You can think of this as the brain changing its own internal weather. It's a slow flooding of ions and chemicals that shifts the entire landscape, basically rewriting the rulebook for when and where all those electrical signals can fire. It's fundamental to everything from your mood to how medications work. Now, layer 4 is the one that's going to blow your mind because it's physical. I'm talking about the actual physical stress and strain on your brain tissue, the squishing and stretching that can trigger signals. I mean, how wild is that? It shows that even the physical structure of the brain is part of this ongoing conversation. And finally, we get down to layer 5, the big, slow, fluid rhythms. This is the rhythmic washing of cerebral spinal fluid that cleans out all the metabolic junk, especially when you're sleeping. It's literally the brain's maintenance crew, keeping the whole orchestra hall clean.
So you've got this wild orchestra of electrical, chemical, and physical patterns all playing at once. How does any of that turn into a useful thought or action? Well, that happens when these patterns line up just right to form something more, a pathway. And a pathway isn't just a random flicker of activity. It's a stable, repeatable corridor for action.
So how do you make one? Well, it's kind of like a recipe with 4 key ingredients. First, you need a structure, a scaffold, for the activity to happen on. Second, the system needs just the right amount of energy, the dynamic level. When you have those two, a repeatable corridor can form. And finally, and this is crucial, that corridor has to actually do something. It has to have a consequence.
And this is the most important thing to get about these pathways. They are completely state-dependent. They don't just exist all the time. They only light up and become functional when the whole system's energy level, or its drive, is in a very specific Goldilocks zone. Not too low, not too high, but just right.
So if the drive is too low, the porridge is too cold, what happens? Well, nothing, really. A signal might start, but it just fizzles out before it gets anywhere. The pathways are short, they're local, and they just can't get any momentum going. But in that middle zone, the just right zone, that's where the magic happens. The pathways become stable enough that you can use them over and over, but they're still flexible enough that you have this huge variety of thoughts and actions you can take. This is the sweet spot. This is a healthy functioning system. And what if the drive gets too high, the porridge is too hot? Well, the system breaks down. It goes one of two ways. Either it gets locked into one single, rigid pattern, like a seizure in the brain, or it becomes so chaotic and turbulent that no stable pathways can form at all. It just fragments. Now, let's zoom all the way back out, because this whole idea, the stacked layers, the pathways, the Goldilocks zone, it is not just about the brain. This is the amazing part. This exact same framework can be used to understand and even forecast major shifts in almost any complex system you can think of. Now, let's be really clear. This is not a crystal ball. We can't predict the exact future event. Chaos theory tells us that's impossible. But what we can do is diagnose what regime a system is in. Is it stable? Is it fragile? And we can forecast the risk of a sudden regime shift. We do it by spotting universal early warning signals. Think about a spinning top. Right before it falls over, what does it do? It starts to wobble more and more, and it takes longer to correct itself. That wobble? That's the early warning signal that a big shift is coming. And so that brings us to the big final question. If this science really can give us the tools to see these warning signs, to forecast the risk of a major tipping point in our societies, our economy, our planet, or even in our own personal health, what is our responsibility to actually do something with that knowledge?